this video for Computer Science 9618, we're going to take a look at the last video in our Ultimate Linked List tutorial video series. This is about building a linked list using a record, and of course we're going to code it out and walk through that code to help you further understand how to build a linked list using a record. Now, a record is a composite data type. We're creating inside of our record a variable name, which will be of the string data type, and a pointer of the integer data type. Now we're calling this composite data type that refers to more than one type of data because we have a string and an integer. We're calling this list item. Now because we have 5 names, we're going to create a 1D array of a specific data type. Not string, not integer, but list item. This means each index in the array will have its own name variable and also a pointer since it is a composite data type. So again, the data type is not a string, it's not an integer, but the data type list item, which we have created, that has the variable name and its own variable pointer, which we'll access. And you'll see that when we code it out. Here's our previous linked list items using a 2D array. We had rows and we had columns. We had a free pointer, a start pointer, a current pointer, and a previous pointer. That's what we had previously. It was the columns that held the name, and then column 1 that held the pointer. This time, because we've created a custom data type, we're going to have one index deal with the name, but that same index also deal with the pointer, and we access it using a dot. So I'll do linked list, whatever index I'm working with, dot name, and I'll be able to update it. Linked list index dot pointer, I'll be able to update it. Let's take a look at the other variables we're going to need. Free pointer, that looks very familiar. We had it in the last program. Start pointer, looks very familiar. We have also had that. Current pointer, that looks familiar as well. And the last one, previous pointer. These are the same variables we had in the earlier videos. The difference between all these videos is the type of data structure that we're storing and implementing our linked list into. So let's go ahead and add the first name. Remember, order of our data doesn't matter. I think you know that by now, especially if you've gone through the first two. It's all about the pointers, so it doesn't matter what row or index our data is stored in the array. Ours again will be in alphabetical order, because if we're doing a linked list, we want to make sure it's in alphabetical order. So let's add our first name. We're going to add Davida. That name definitely looks familiar by this point. To figure out where to put Davida, we look at our free pointer, just like we did in the previous videos. This will tell us which index to put Davida. Now, because of our record, our item Davida, she has a name, but she also has a pointer. So we need to access these using a dot. For example, linked list, whatever index I'm working with, I'm going to put dot name. Then I can assign the name to my linked list array. But my data type also has a pointer. So I type in linked list index, whichever index I'm working with, dot pointer, and I'll be able to assign a pointer. So I can use the same index and just access the name from my record, update it, the pointer from my record, and update it. Now our free pointer tells us which index to put our composite data type list item into, and it says to put it in index 0. So let's go ahead and add Davida to index 0 and talk about what is happening. And when we want to add Davida, it's all about that free pointer that tells us what index to put Davida into, and that is index 0. So I need to access the name of index 0, but also the pointer, and I'm going to start with that name. And I need to put Davida inside the dot name property of our array that we have of list item. Then I need to also access the pointer, which is located in index 0. That's -1. And because Davida is the last item in my linked list, it's going to stay at -1. The next thing I need to do is I need to change that start pointer and my free pointer. I'm going to start with my free pointer. Because Davida is taking up index 0, I'm going to increment my free pointer to 1. My start pointer is no longer going to be -1 because it was -1. What it's going to be now, though, is going to be 0 because it's starting at index 0, which is Davida. And Davida has both a name and she has a pointer, and we access it by using dot name dot pointer. My linked list is of the list item data type, which is a composite data type that has a name and a pointer. So let's code out what we have so far, and let's account for the first name, adding that to our program. So we're over here in VB.net. You can see I have our record list item. Now in VB.net, the way to create a composite or record data type is doing public structure. You can see I have a composite data type here. It refers to more than one data type. It refers to a string, and it's referring to an integer. So we're going to do name as string, pointer as integer. Each index in my linked list, I'll be able to access a name and pointer. Very similar to a 2D array, except for instead of using columns, I'm actually going to use these variable names, name and pointer. Here we have our linked list. We've created 1D array of list item. So each index is going to have these two variables, which we just said. Current pointer, making a return, as well as previous pointer, free pointer, and start pointer. Those are the variables we're going to need in our composite data type to get us started. Let's take a look at adding the very first item. So down here in the procedure add item, I have dim item as string. I wanted to use item as our composite data type name, but I can't. And that's because I want to keep the code as similar as possible for you so you can understand the only code we're really changing is the data structure that handles the linked list. If I start changing all this code, it may be a little harder to follow what is going on. I want you to be as successful as possible, be ready as possible by firmly understanding how a linked list can be implemented in different ways. So you'll notice this code looks almost identical, and that's because it is. We check that free pointer. If it's not equal to -1, we're going to get the name. What name do you want to add? So we're going to add Davida. If it is -1, then there's no room in the linked list because no index is free. Now, if our free pointer is 0, and this will account for the very first item, Davida, which we are adding. If our free pointer is equal to 0, then I want to update linked list index 0. I want to update the name. What am I putting inside the name? The name that the user entered. Then I want to update Davida's pointer to -1. Why is her pointer -1? Well, she's the first item in the linked list, but she's also the last item in the linked list. She's the only item in the linked list. There's nothing for her to point to, and the last item in our linked list should always point to -1, which is a null pointer. That signifies the end of our linked list. We need to increment free pointer just like we did in both previous videos. Davida is taking up index 0. When I add my next name, I don't want to overwrite Davida, so I need to increment my free pointer, which is now pointing to the next available index to put a name into, which is going to be index 1. My start pointer is no longer -1. Because Davida is inside of our linked list, we need to put our start pointer at index 0 so it can point to Davida and then output her name and her pointer. We give a message item was added and we exit the sub. There's no point in running any other code in our add item because we're adding the first item. We don't need the other code to run at all because we're only adding the very first item, and that other code is not needed when you add the first item. But let's swing back over and take a look at adding another name to our linked list and what needs to update. Now we're going to add another name, and we're going to add Betty. Now to figure out where to put Betty, we look at our free pointer again. It's all about those pointers. This will tell us which index to put Betty. Now we're going to put her name and her pointer at this index because remember our record has two things to deal with, name and pointer. So we look at our free pointer, which is 1. We're going to go to index 1, and under linked list, whatever index we're at, which in this case is 1, we're going to deal with the name, and that is where we're going to place Betty. But we also need to look at that same index and address the pointer variable. So the first thing I need to do is I need to figure out, okay, what is Betty's pointer going to be? Well, I need to take my start pointer, load it into the current pointer because I'm starting to go through this loop trying to figure out the place to put Betty into. So my current pointer is 0. I'm comparing Betty to Davida, Betty is less than Davida. And when that's the case, I need to take the start pointer and I need to put that right there into Betty's pointer, because Betty, after we run Betty, it needs to point to Davida. Davida is still pointing at -1, and that is fine. What I need to do, though, is I need to update that start pointer, because it's no longer going to start with Davida, it's going to start from Betty. So I'm going to take that free pointer, I'm going to move it into, or copy it over to the start pointer, and then all I need to do is update my free pointer to index 2. So let's update our program to account for more than just the first name. Then after we write the code, we're going to trace through the code, adding the rest of the names. So here's the code for what we just did. In this line of code, we add Betty's name. We set these two pointers up, ready so we can traverse through this loop. Let's check the condition of our loop. Well, current pointer is not equal to -1. It's not. Our current pointer right now is 0. And while Betty is greater than Davida's name, Betty is not greater than Davida's name. So this loop doesn't even run. So we jump down to this if statement. If previous pointer is equal to -1, it is, because we set that right here. So this part of the if statement is going to run. We're going to take our start pointer, which is index 0, and we're going to give Betty that pointer so Betty can point to Davida. Then we're going to take our free pointer, which is index 1, and that's going to be our new start pointer. So when we run the linked list, it will start at Betty, and then Betty will point to Davida. There's only one thing left to do for Betty's code, and that's the free pointer from index 1 to index 2. Let's take a look at how to add some more names and trace through this code. All right, it's time to trace the code that we just wrote by adding another name, Clark. Now to figure out where to put Clark, we're going to look at that free pointer. This will tell us which index to put Clark's name and his pointer into. Our free pointer is 2, so we're taking a look at these 3 statements right here. The first thing, linked list free pointer dot name equals item. So my free pointer is 2, so inside index 2, I'm going to put item, which is Clark, right there under the dot name property of my linked list. The next thing I need to do is take my start pointer, which is 1, because the linked list starts with Betty, put that in my current pointer, and then my previous pointer at -1. This will allow me to set it up and enter this loop right here. So my current pointer is not -1. It isn't. It's 1. And while the item, Clark, is greater than where we are currently, which is Betty. Clark is greater than Betty. So what I need to do is I need to update my previous pointer, and my previous pointer is not going to be -1. It's going to be my current pointer, which is 1. The next thing I need to do is update my current pointer by looking at the linked list current pointer 1 dot pointer. That is 0. This will allow me to go to the next item in the list, which is Davida. Again, we've put in Clark's name, but we're trying to decide what his pointer should be, and that's why we're traversing through the name. So now my current pointer is 0. We go back to the beginning of the loop. While the current pointer is not -1, it isn't, and while Clark is greater than Davida, that condition is not met. So now we are exiting the loop and heading to these if statements. I check my previous pointer to see if it's equal to -1. My previous pointer is 1, not -1, which means we need to jump down to these else statements. In my linked list, free pointer dot pointer, now we're updating Clark's pointer. What are we putting in Clark's pointer? We're putting in our current pointer, which is now 0. If I follow this, based on what I have right now, it'll go to Betty, then it'll go to Davida. So we need to update Betty's pointer too. And Betty's pointer, and when we look at the second line here in this else statement, what are we putting in there? We're putting our free pointer. So now when it starts at Betty, Betty will point to index 2, which is Clark. Clark points to Davida, which is index 0. Davida points to -1, showing it is the end of our linked list. All right, it's time to add our next name, Alfred. If you've been following along, then you know Alfred comes next. Now to figure out where to put Alfred, it's all about that free pointer. This will tell us which index to put Alfred in, which is going to be index 3. So let's take a look at our code. It says linked list free pointer, which is 3. So linked list 3.name, we're putting in that item. We're putting in Alfred. The next thing we need to do is set up our current pointer with our start pointer. So our current pointer is going to be set to the value of 1. Our previous pointer equal to -1 to find out if Alfred should go at the beginning of the list. So we head over to our while loop. Our current pointer is not equal to -1. That checks out. But the second condition, item is greater than linked list current pointer.name. Alfred's not greater than Betty. That condition is not met. So we jump to these if statements. If my previous pointer is -1, which it is. So what I need to do is I need to update Alfred's pointer. Alfred's pointer is not going to be -1. It's going to be my start pointer, which was the value of 1. And this is so Alfred can point to Betty. I want to do that before I update my free pointer, because the next thing I need to do is update my, sorry, not the free pointer, my start pointer. My start pointer is going to have the value of my free pointer, which is 3. That way the list starts with Alfred. But notice Alfred is pointing to index 1, which is Betty. Betty's going to point to Clark. Clark is going to point to Davida. Davida points to -1, which is the end of our linked list. So that is how we add Alfred. The next thing we need to do is we need to traverse and output. So now that we can see how the code works with this record, it's time to put it to the actual test. So let's update our procedure that will print the linked list using a record. Now we're going to add something extra again that allows us to print the array too, so we can see how the array contents are different from the linked list, which is all about the pointers. So let's swing over to VB.net and code it out. So here's our print list code. Remember, this is extra code that is not needed. This prints the array so you can understand how the array is different from the linked list, because order of the array does not matter. It's the pointers in the linked list that matter. We load current pointer up with our value of our start pointer, which is going to start with 3. As long as we're not at the end of the list, we're going to print the person's name. So Alfred would be up first. We're going to print Alfred's pointer so we can see it. Then we're going to take Alfred's pointer and we're going to load it into current pointer. And after Alfred is Betty. So because Alfred's pointing to Betty, we need to load that into current pointer so we can print Betty's name and then Betty's pointer. So let's go ahead, let's run our code. Let's add Davida. Let's add Betty, Clark, the same order that we did in the presentation. And we can see we have Davida, Betty, Clark, Alfred inside our array. But we start with Alfred. Alfred points to index 1, which is Betty. Perfect. Betty points to index 2, which is Clark. Clark comes after Betty. Clark points to index 0, which is Davida. Davida comes after Clark. Davida points to index -1, which signifies the end of our linked list. Now there's one more procedure we got to talk about, and that is removing an item from the linked list. All right, the last thing we need to do is remove an item from the linked list. Now, when we remove the item, what you are actually doing is adjusting the pointer so the index is skipped over, just like we did in the 2 previous videos. Remember, we need to update the pointer value and not the name. We're adjusting only the pointer because linked lists work on pointers. So we're going to trace the code we'll use so we can see what is happening and, more importantly, how it works. It's not about having the code, it's about understanding that code. So let's go ahead and let's remove Alfred. Let's start with him. We added him. Well, let's remove him. So the first thing we need to do is take our start pointer and load it up into our current pointer. We have done that. Then we need to load -1 into our previous pointer, and I have done that here. Once we do that, we can move into this while loop. Well, my current pointer is not equal to -1. It isn't, and also found equals false. Both of those conditions are true. We have an and condition, so both of those conditions are true. Current pointer is not -1 and found equals false. So we check this if statement. If our item, Alfred, equals linked list current pointer, my current pointer is 3, Alfred is equal to Alfred. So found equals true. Then because I'm inside this first if statement, I'm going to use this inner if statement. I check to see if that previous pointer is equal to -1. Is it? Yes, it is. So I need to update my start pointer. Now, my start pointer was 3. This time what I'm doing is I'm taking the pointer of Alfred, which is 1, and that's going to be my new start pointer pointing to Betty. I need to update the start pointer because Alfred's the first item and we need to skip that over. So we're loading up our new start pointer with the index of 1, and that will point to Betty. It will say the name was removed because our condition is no longer true because found isn't false, it's now true. Let's remove Clark. So I'm going to take my start pointer, put it in my current pointer. I've done that down here. And the previous pointer equal to -1, and we have set that up. We're now ready to enter our while loop. Well, our current pointer is not equal to -1. That checks out. And found equals false, and it does. That checks out. So I check this first if statement. If Clark is equal to Betty, well, it's not. So I'm going to skip over these if statements because this first one's not true, and I'm going to jump all the way down to this else statement doing these 2 lines. I'm going to take my current pointer and put it in my previous pointer. Well, my current pointer is 1, so I'm going to get rid of that -1, put that in my previous pointer, and then I need to update my current pointer with the linked list current pointer, and my current pointer of 1. Betty's pointer is 2. That allows me to move on to the next item, which is Clark. So this else statement allows us to move on to the next item in the list. We start back over at that while loop. Both conditions are met. So then I check to see if Clark is equal to Clark. That checks out. So found becomes true. All I need to do now is check whether or not it's the first item, and I do that by checking the previous pointer. So if previous pointer equals -1, that condition is not met, so I jump to this else statement. Our linked list previous pointer dot pointer equals linked list current pointer dot pointer. We'll look at our previous pointer. Linked list 1, what is Betty's pointer now equal to? It's now equal to where we currently are, Clark's pointer, which is 0. So we need to update that pointer right there, and then we exit the loop. It doesn't matter that multiple of these are pointing to 0. None of that matters. Notice Alfred's pointer is still at 1. That's okay. We have removed Clark and Alfred. My start pointer is 1. When I look at Betty's pointer, it's 0, which is pointing to Davida, which is pointing to -1, which will end our linked list, and we output the name was removed. So let's run our program, do a final check, and then conclude this video series. So here is our remove item code. I have item as string, found as boolean. What item do you want to remove? And this is everything that we just looked at. And we set up the pointers so we can start traversing the loop here. So we enter the loop. Well, current pointer is not -1, meaning we're not at the list and we haven't found the item yet. We're checking to see if that item that we entered is equal to where we are in our linked list. If it is, found is set to true. Here, we check to see if it's the very first item like we did with Alfred. Why? Because we need to update that start pointer so it skips over Alfred. If it's not, it's like Clark, then what we're going to do is we're going to adjust the pointer so Betty skips over Clark, and we do that by grabbing Clark's pointer. So that's what current pointer is, and we put that into Betty's pointer. This else statement down here allows us to move to the next item in the linked list if it doesn't match. And then if found equals true, the name was removed. And then if we enter a name that's not present in the array, then found never equals true, but we do hit current pointer at some point being -1, especially when we hit Davida. So if we hit Davida and the name hasn't been found, then the name is not present in the array. The next thing we need to do is go up to our sub main. So what we're going to do is we're going to print our list. We're going to remove an item, and then we're going to remove another item, and then we're going to print our list. So what we're going to do is we're going to remove 2 items, and then we're going to see if our linked list works. And it should work. A lot of the code in this video series is exactly the same. All you're doing is updating the data structure. So let's add Davida, Betty, Clark, who's Alfred, and then we can see here we have Davida, Betty, Clark, Alfred. You know, I want to add Elijah, so let me run this 1 to 5 times so we can do 0 to 4. So here we go, 1 to 5. Let's try it again because I want to add that Elijah name in there. So we're going to do Davida, Betty, Clark, Alfred, Elijah. So we check our original linked list. Alfred points to index 1, which is Betty. Betty points to index 2, which is Clark. Clark points to index 0, which is Davida. Davida points to index 4, which is Elijah. And now Elijah is pointing to index -1. So that proves by adding that extra name that our linked list does work. We're going to remove Alfred, and you want to spell his name correctly. And we're going to remove Clark. Now, when we check our linked list, it should start with Betty, Davida, Elijah. And here you can see Betty, Davida, Elijah. Betty points to index 0, which is Davida. Davida points to index 4, which is Elijah. Elijah points to index -1, which signifies the end of our linked list. Hope you guys found this entire video series helpful. If you did, please take a moment to give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.